Namaste and a very, very good morning to all of you. My name is Mithun, and in today's presentation, I'll be talking about automatic linear models. Usually, I prefer running the traditional linear models itself. Let me show it for you. Analyze, regression, and the second option. Traditionally, I would always go with the linear models, but you also have another interesting option, which is called as automatic linear modeling. This is the very first item under the regression model. Now, when do we use automatic linear models? If you want to show a lot of graphical display, if you want to show visualization to the end user, then there are a lot of interesting charts, graphs, and visually appealing insights that we can derive from automatic linear modeling. So the topic of today's discussion will be automatic linear modeling, and to show some of the useful outputs and results emerging from automatic linear models, I will be using the car sales data. To run the car sales data, I can click on File, Recently Used Data. It shows the 10 recently used files. I will choose the second file, which is called as car sales file. If you have been following my earlier videos, you will be familiar with this particular data set. You have vehicle description, like who is the manufacturer of these personal motor vehicles. You have the model of the vehicle, sales, resale value, type, price, engine size. And if I scroll further to the right side, you see other vehicle characteristics like horsepower, wheelbase, width, length, curb weight, fuel capacity, mileage per gallon. You also have log transformed sales. What is the sample size in this data set? The sample size is 157. So I've got 157 cases in this data set. I want to build a model to identify which are the key variables which affect sales. So sales is my dependent variable, and all the other variables that you see, like price, engine size, horsepower, wheelbase, width, so on and so forth, all these will be my independent variables. To run an automatic linear model, let me click on Analyze, then choose the option Linear. I will be clicking on the very first item here, Automatic Linear Modeling. If you are using a lower version of SPSS, which is lower than 15, you might not see this particular option. Automatic linear modeling might be absent. I'm using SPSS 26.0, and therefore this particular option is available in my system. Automatic linear modeling, let me click on this. The moment you click on this, the ALM, or the automatic linear modeling dialog box opens up. You see all the variables being considered as predictors. If I don't want this, I will choose the second option here, use custom field assignments. I repeat, use custom field assignments. I have to specify the target and the input variables here. My target variable will be sales. What about the predictors? Important variables like 4-year resale value, vehicle type, price, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, and fuel efficiency, all will be my predictors. These are the input variables which influence sales. There are a couple of interesting things that you could do here. Please click on the Build Options tab. What is your main objective? So depending on what's your main objective, there are 4 options which are highlighted. Either you can create a standard model. Second, if you want to enhance the model accuracy, you can use the boosting technique. If you want to enhance the model stability, you can use the bagging technique. If you want to create a model for a very large data set, you would require a server. Now, I will go with the standard model. There are other options here, like basics. Here, you can automatically request SPSS to prepare the data for you. I repeat, you can prepare the data for you. Many times when we have noisy data, that is, we have too many outliers in the data, a lot of missing cases and such things, it becomes a bit difficult to get a good, reliable result. This is where automatically prepare data option comes in very, very handy. Model selection. If you have a lot of variables, like let's say 20, 25 variables, and you want to identify only 5 or 6 most important variables. From 20 independent variables, I want to drill down to only 4 or 5 most important predictors. I can use a variable selection method. The default option is forward stepwise. You also have other options like best subset, but here I want to see all the variables and its significance value, and therefore I will choose the option include all predictors, which means I'm not selecting any particular method here. You can ensemble the model if you want. This is the option for boosting and bagging. I'm not going to boost or bag the data set, and you can click on the advanced options if need be. I'll go to model options now. If you want to save the predicted values to the data set, you can create a new field called as predicted values. I'll run this model now. Very quickly, SPSS gives me the output. This is the output viewer, and I can see the model summary table. You have some description about what is the target variable, is the ADP or the automatic data preparation option on or off. The model selection method here is none, and the information criteria is also given. At a very high level, if you want to understand the quality of the model, whether your model is good or bad, you can look at the length of this particular blue bar. This is the accuracy metric, and at the back end, we are using the adjusted R-square. As you know, if the adjusted R-square value is close to 100%, it means that the model fits the data well. Here, the adjusted R-square is barely 25%, which means that 25% of the variation in sales is explained by the vehicle characteristics that I have entered, which is not such a good model. Ideally speaking, if the R-square value is exceeding 75%, you can be happy because it means that the model fits the data well. Let me just double click on this. The moment you double click, the model viewer will be activated. So this is the very first tile that we are looking at. That is just proceed. Even before you proceed, if you just highlight on the blue bar, it displays the adjusted R-square as 0.246. Adjusted R-square is good if you are comparing two models with a different number of predictors. Let me click on the second tile here. It says automatic data preparation. You can see all these independent variables have been transformed automatically by SPSS. Curb weight, engine size, fuel capacity, horsepower, all these 11 variables have been transformed. What is the action that SPSS has taken? It has trimmed outliers and it has replaced missing values. Now, this is the benefit of using the automatic data preparation. You don't have to manually look at each variable, what is the missing case, what is the percentage of missing cases, and what action you need to take. That problem is avoided, and you can automatically use SPSS ADP to impute for missing cases as well as trim the outliers. What is the benefit? The benefit is that it saves a lot of time for us. The next graph is very, very useful because it says predictor importance. Out of all the variables which impact sales, the most important variable seems to be curve weight. Its predictor importance is 0.29. Second most important variable is vehicle type, and the third most important variable is engine size. So curve weight, vehicle type, and engine size are the three best predictors as per this model. If you look at some of the not so good predictors, you look at price, width, and wheelbase. These three variables are not that important in predicting sales. This can be called as counterintuitive result because we are getting price as the least important variable. When we say least important variable, this is a bit of a question mark because price and such variables will be at the top of the customer's mind when they buy a vehicle, right? So here, price is coming out to be unimportant, possibly because we are using the unstandardized coefficients and not the standardized coefficients. Let me scroll down. You see the distribution of the predicted value versus the observed value here. Ideally, we would like to see an ellipse here. If I look at the next tile, what you see here is the distribution of residuals. The target variable is sales. When you plot the residuals, you should be able to see this particular diagram. This is called as a histogram. Here we're checking for the normality assumption. Do the residuals follow normality or not? If the variable follows normality, it's a good sign. On the other hand, if the variable residuals does not follow normal distribution, it is a bit of a problem, especially if you're doing hypothesis testing and such things. By default, you get a histogram. You can change it to a PP plot as well. So here again, we are plotting the residuals. We are observing what is the distribution of residuals. If these data points are lying along the 45-degree line, you could conclude that the variable residuals follow normality. I see some area here wherein there is a level of departure from normality. However, that level of departure from normality is not a significant departure. Let me scroll further down. This is interesting. You have the record ID. SPSS displays the 6 records wherein the Cook's distance is very, very high. This is very, very important for us to do outlier analysis. What is Cook's distance? You can look at the description here. Records with very large Cook's distance values are highly influential. So those records, for example, record ID 57 has a high Cook's distance value. Similarly, record number 53, 138, all of these guys have high Cook's distance value. If Cook's distance value is close to 1 or greater than 1, we will be very, very worried, because we have to go back to the data, investigate it, possibly remove that particular record ID, because it influences the model computations, and such records may distort the model accuracy. So this is a very, very useful table, and you might want to pay attention to this, especially if the coefficient values are not in line with your expectations. Let's proceed further. You can see all the independent variables listed here. These are all the independent variables. It says curve weight transform. Why transform? Because there were a lot of outliers and missing cases. And here you can see the distribution of the dependent variable. This is the dependent variable. You can see here it is not normally distributed. You can look at this particular icon. The preview is quite clear. The variable sales is positively skewed. We might want to use a log transformed sales rather than the original variable of sales, because regression model does well with log transformation as opposed to the original variable. Now, how do we interpret this particular graph? This graph is telling you the effect of each of the variable on my dependent variable. Thicker the line, when you look at these lines, thicker the line, bigger the impact. Thinner the line, weaker is its impact on the dependent variable. Which are the 4 or 5 most important predictors? I can say curve weight, type, engine size, length, and horsepower. These are the 4, in fact, these are the 5 most important variables. I repeat, curve weight, this is the first variable, followed by type. We have engine size, length, and horsepower. All these variables have a huge impact on sales. If I hover the mouse here on any of these variables, you will be able to see a small description of the variable. Also, you can look at what is its importance as well as the significance level here. So this is the significance level for the first variable, that is curve weight. It says 0.006. And we know that if the significance level is less than 0.05, such a variable is significant. So we have to take it seriously. Let me look at the next chart. Very, very interesting chart. If you compare the earlier chart, you could see only a monochromatic color. You couldn't distinguish whether a variable had a positive impact or negative impact. I couldn't say curb weight, whether it is having a positive impact on sales or negative impact. But please, let's look at the next tile. You can see here, there are two different colors that are being used. Variables which have a positive impact are coded as blue, and the variables which have an orange color, variables which have a negative impact, are coded in orange. So when you look at the intercept term, when you look at curb weight type, also horsepower, they're all orange in color. And you can see here, they are having a negative impact on the variable sales. The same argument holds good even for price, because if you increase price, sales will come down. So no wonder it is colored in orange. Some of the other variables like engine size, length, fuel capacity, mileage per gallon, and wheelbase, these are all colored as blue because they have a positive impact on the dependent variable. Let me look at the last tile here. So this chart, the earlier chart, is the coefficients table. So many times this is very, very useful because the clients basically will be able to relate to this particular chart and the earlier chart, rather than having a very, very long list of model coefficients along with its p-value and confidence interval. Now, this is a very interesting chart because here I'm able to see the estimated mean. On the y-axis, I have sales, and here I have the curb weight. In the x-axis, I have curb weight. What this says is basically, you can see a drop in the line, indicating that as the curb weight increases, sales, the marginal means of sales go on reducing. So sales is higher if the curb weight is approximately 2, but as the curb weight increases to 5 units, the sales keeps dropping. Now, this chart is very, very different as compared to the second chart here. Here we see a completely different trend. Here we are comparing between automobiles and trucks. So when you look at trucks, the average sales is on the higher side, but when you look at automobiles, the average sales is $40,000. Here for trucks, it is hitting approximately 20,000. My apologies, it is 90,000. If we scroll further down, here again you see an increasing trend, which means that when the engine size variable increases, the estimated sales also increases. So this is very, very good because it does bivariate analysis, and we can use this as exploratory data analysis and show this to our client. There is a very, very interesting description here. It says estimated means charts for the top 10 significant effects. That is, wherever the p-value is smaller than 0.05, for those variables, it is highlighting the estimated mean. And we have the final tile here. It just gives you basic description of the model. What is linear model? Linear model predicts a continuous target based on the linear relationship between the target and one or more predictors. What all fields we have used, it is listing. The target variable is sales. These are some of the predictors that I have used. I have not partitioned the data set. What are some of the building options that I have listed for myself? You can see here, what is my objective? My objective was to create a standard model. Remember, I have not used boosting or bagging. And I had requested for confidence interval. I had automatically prepared the data. The model selection I chose as none. When it comes to advanced, what is the random seed that was used, that is being displayed. So all this summary information is very, very useful if you are showing this to your boss or maybe to your guide. You can see the training summary, linear models, what is the sample size, the model type, it says is classification. And further, it just goes on to highlight all the predictors that were used for the model. So this is what I had in today's presentation. So this is about ADP, that is automatic data preparation, which is one of the features in automatic linear modeling. So with this, I've come to the end of today's presentation. To summarize at a very high level, the things that we looked at automatic linear modeling, what is adjusted R-square, the model coefficients, and what is the kind of impact that it has on the dependent variable, and some other model description. Thank you very much for watching today's presentation. I request you to subscribe to my channel and share my videos with your friends and relatives. Thank you very much again, and have a great day.